Okay, let's try to understand what an inverse function here is. So I've got a mapping of a simple function, f, and this is a function because each input has a single output. And now let's look at f inverse. F inverse simply reverses the mapping. So now the f inverse takes 1 and sends it back to 2 and back to 3 where it came from in the original function. So a few things about this. The idea is very simple, right? Notice that f, the original function, is not 1 to 1. The reason is it's 2 to 1, right? It's 2 to 1. That means that when you reverse that, it's going to be 1 to 2. F inverse is 1 to 2. When you have 1 going to two different places, it is now not a function. So in general, f has to be, the original function has to be 1 to 1, so that the inverse is actually a function. So this is very important. The original function has to be 1 to 1. That's why we explore the property of a function being 1 to 1, so that we can consider the inverse. Also, the notation here for f inverse is maybe not what you would expect. So that's why I wrote the words out, f inverse. The notation for f inverse is the original function f with what looks like a -1 exponent. So that's how we write f inverse. This is not reciprocal or anything like that. This is not an exponent. It's just simply read as, if this is a function, if f is a function, then the -1 exponent means this is the inverse function. Okay? Okay, a few other things here, a few other properties of inverse functions. Clearly, every x value over here in the original function is now a y value. So x becomes y, and vice versa if you go the other way. The domain of this function becomes the range of this function. So let's see, x becomes y, the y for the original becomes the x for the inverse. So let's just write it like this. Sorry. X and y are interchangeable when you switch from the original to the inverse. The domain and the range are interchangeable. And clearly the input and the output, if you'd like to consider it like that, are interchangeable. Right? The input's here, the output's there, the output's here, the input's there. Okay? And this leads us to lots of interesting things, lots of interesting mechanics when you work on inverse functions. So here's a question we can answer now. So f, the original function, is 1 to 1, and f of 2 is -3. What does this tell us about f inverse? Well, first of all, since f is 1 to 1, that tells us f inverse is a function. Okay? Second of all, f of 2 is -3. Now, 2 is the input, or the x, and -3 is the output. So that means for the inverse, it's going to switch. So 2 is the output when 3 is the input. Very important. This is for the inverse function. So if I were to write that in function notation, I'd write f inverse, because that's my function, of something equals something. My input is what goes here. Well, 3 is the input to the inverse function. My output is what goes here, and that is 2. So f inverse of 3 is 2, because f of 2, -3 is the output up here, so -3 is the input down here. F inverse of -3 is 2. Alright, so now we're going to look at something a little harder. The original function is given as an equation, some formula for it, and now we want to find f inverse of 7. Well, 7 is the input to f inverse, which means it is also the output of f. And the output of f in general is 2x plus 1. So that means 7 equals 2x plus 1. And now if we solve this for x, I'll subtract 1 to get 6 and divide by 2 to get 3. X is 3. So that means f inverse of 7 is 3. The reason for that is because f of 3 is 7. Right? You can use the formula to check. 2 times 3 plus 1 is 7.